Artificial intelligence is rapidly transforming our world, and today we are exploring its most cutting-edge applications in creative industries.
Welcome to the Deep Dive. Today we're tackling a really big question in AI development. What's the real way forward for advanced AI? Is it just about making models bigger and bigger, or is there a smarter way, maybe something more like, how our brains work? We're diving into a pretty cutting-edge AI architecture called the Hierarchical Reasoning Model, HRM, for short from Sapient Intelligence.
That's right. HRM is, it's quite novel. It's brain-inspired, designed specifically for deep reasoning, but with surprising efficiency. It really throws down the gauntlet to the dominant idea of just scaling up large language models, the LLMs everyone talks about. So yeah, we'll unpack how it works, look at the, frankly, bold claims they're making, and touch on the big questions this raises for AI's future.
Okay, so our mission today, for you listening, is to really cut through the jargon, get to the core of HRM, based on the research and analysis out there.
Yeah.
So you've probably heard tons about large language models. They're amazing, right?
Yeah.
Generating text, code. But that deep multi-step thinking, that can be a struggle.
It often is.
We have these workarounds like chain of thought, prompting, basically getting the AI to think out loud. But, and this is key, that feels like a patch, doesn't it?
Exactly. It's a workaround and often a really inefficient one, computationally speaking. It doesn't fundamentally change how the model reasons. The core idea behind HRM, sort of their big insight, is that language isn't thought itself. It's how we communicate thought.
Okay.
Our brains, they do complex reasoning, long chains of it, in this sort of latent nonverbal space, thinking in concepts before words. Sapient's view is basically architecture over sale. Build models that are intrinsically good at reasoning, more like a brain.
Interesting. So architecture over scale. Let's get into that architecture then. How does HRM actually do this reasoning?
Well, it uses this neat dual module system. Think of it as having two parts. A high-level module, they call it the CEO, which does the slow, abstract planning.
The big picture thinking.
Precisely. And then there's a low-level module, the worker, which handles the fast, detailed calculations, the grunt work.
Okay, CEO and worker, how do they talk to each other?
That's the clever bit. It's called hierarchical convergence. The CEO module basically points the worker module towards a specific part of the problem. The worker focuses, computes, finds a kind of local solution and equilibrium,
right,
and then reports back up. The CEO takes that result, reevaluates the whole strategy, and then directs the worker to the next strategic step.
Okay, I think I get it. Like maybe solving a really tough Sudoku. You don't just stare at the whole grid, right?
Exactly. You focus on one box or one number, figure that bit out, then you zoom out, see how that changes the bigger picture, and then decide where to focus next. HRM does something analogous, allowing really derp computation without getting stuck.
That makes a lot of sense, actually. And the performance they're claiming is kind of staggering for such a small model, isn't it? HRM is tiny, like 27 million parameters. For context, big LLMs have billions, even trillions.
It's a huge difference.
And it apparently trains on just like 1,000 examples for each task. No massive pre-training data. They're reporting near-perfect scores on really complex puzzles like Sudoku Extreme and Maze Hard. These are things where even the best LLMs using chain of thought just fail, like 0% accuracy.
That part does seem quite clear, the success on those specific algorithmic tasks. But there's a but. It's performance on the Abstraction and Reasoning Corpus, the ARC-AGI benchmark, which is meant to test more general reasoning. That's where things get a bit contentious.
Oh, also.
Well, Sapient Intelligence had put out different numbers themselves, sometimes 5%, sometimes up to 55% on subsets, but these haven't really been validated on the public independent leaderboards yet. So naturally, there's some skepticism. Some researchers wonder if maybe it's overfitting to those specific tasks rather than showing true generalization.
Right, the overfitting question, always tricky. But okay, even with those caveats, why should you, our listener, really care about this specific model?
Well, the efficiency is just off the charts. It reportedly runs in milliseconds on a normal CPU, uses less than 200 megs of RAM.
Wow, okay, that's tiny.
Which makes it potentially perfect for running AI directly on devices, Edge computing. Think about possibilities like helping diagnose rare diseases maybe, or improving climate forecasting. They actually made a bold claim there too, 97% accuracy for certain long-range weather forecasts.
Weeks or months out, that would be huge.
Exactly. Or maybe being the decision brain inside next-gen robots, running right on the machine itself.
And crucially, they've open sourced it, right? The code, the models.
Yes, absolutely, which is great. It allows the whole research community to poke at it, verify the claims, build on it. That transparency is key for moving forward and getting that independent validation.
Okay, so wrapping this up, what's the big takeaway here? HRM seems like strong proof that AI architecture really, really matters. It's not just about scale.
Definitely. It challenges that dominant narrative, but it also presents this kind of, well, call it an efficiency paradox. It's super efficient because it's highly specialized in reasoning.
Yep.
The huge question then becomes, can you take this pure specialized reasoning engine and somehow combine it with or extend it to include broad world knowledge, the stuff LLMs are good at? Is that the path to artificial general intelligence? Or will HRM remain this incredibly effective but ultimately narrow specialized tool? It's a fundamental fork in the road, potentially.
Yeah, specializing versus generalizing. It really leaves us with a thought to chew on, doesn't it? As AI keeps evolving, where do you think the future lies? Is it these ever larger generalist models or these focused brain-inspired reasoners like HRM?
Yeah.
Or maybe some kind of powerful hybrid, a blend of both approaches? Makes you wonder,